why I'm in this math class. Fundamental identities, like when am I going to need to use this? I just, forget it,
Excuse me, sir. You look like you could use some serious math help.
Who are you?
Well, I'm the math wizard. I
didn't call for a math wizard, I'd rather call for a Call of Duty.
Oh, poppycock. How about I instill upon you and inside your very bones the magical math powers?
I don't want you to instill anything inside of me.
Nonsense, nonsense. Hegergurk.
Oh my god, this math! It suddenly all makes sense, you're amazing!
But doesn't it?
Oh my god, I'm gonna do this right now! Okay, so here we have our identity. On the top half we have, in parentheses, secant theta minus tangent theta squared plus 1 over secant theta times cosecant theta minus tangent theta times cosecant theta, which is all equal to 2 tangent theta. So we have to get to here. So we're going to start on the top real quick. First we have to FOIL the top. Because if you notice, we can't, even though it's very close to a Pythagorean identity, it is not exactly it because it is not squared on inside of it. So what we're going to do is, we're going to do secant theta minus tangent theta times secant theta minus tangent theta, which will equal out to secant theta squared minus 2 tangent times secant theta plus tangent squared theta. So then we can take that and put that back on top. Okay, next, we can notice now in the top that we actually do have a Pythagorean identity. It is tangent squared theta plus 1, which we put here. If we notice the second one, 1 plus tangent squared theta equals secant squared theta. So we could put that in the top. Alright, so what can we do now? If we notice, we have two, numbers and stuff up here on the top. Secant squared theta and another secant squared theta. So we can add those two together to get 2 secant squared theta. Now, the next thing we're going to have to do is factor. If you notice, we have both another 2, we have 2 2's in the top, and then we also have a secant. We have, secant squared and then a regular secant. We can factor out both those terms. And so that we are left with secant theta minus tangent theta in parentheses. Okay, so now we're going to have to do the same thing in terms of factoring on the denominator. We have 2 cosecants. We have one right here and one right here. We can take those outside. Now, if we notice, we have 2 of the same things on the top and the bottom. We have a secant theta minus tangent theta on the top, and we also have one on the bottom. We can then cancel, reduce, whatever, so that we are left with 2 secant theta over cosecant theta. Now, if we have that, we can then look at our list of identities that we have, and we can notice under our reciprocal identities, we can go to, for cosecant, we could switch it to 1 over sine theta. So, for the bottom, we're going to have 1 over sine theta. And then on the top, we'll leave the 2, and then secant is equal to 1 over cosine theta. So we'll set that. Now, as every good math student knows, we can't have, a problem looking like this. We can't have fraction on the bottom or really on the top. So what we're going to do is we're going to multiply the bottom by the reciprocal. Same thing as we're going to multiply the reciprocal at the bottom on the top also. And so this cancels out, becomes 1 really. And then we're left with on the top 2 times 1 over cosine theta times sine theta over 1. Now, because this is not addition or subtraction, we don't have to find a common denominator, so we can multiply straight across the top. 1 times sine theta is equal to sine theta. And then cosine times 1 is equal to cosine theta. Now, once again, if we look at the reciprocal identities, or rather quotient identities, we will notice that tangent is equal to sine theta over cosine theta. And so then, we're able to reduce down to 2 times tangent theta, which equals 2 tan theta. And that is what we were originally going for. So, there we go. That's how you figure this one out. I never thought I'd be able to do that, but wow, I actually understand how to do identities now. Awesome. Whoa, hey, thanks Math Wizard, you really actually helped me know how to do this.
And now that you're a math wizard, you can help kids too!